First thing we're going to talk about is linear equations. An equation is just a statement that two expressions are equal. So x plus 2 is equal to 9 is a statement that the expression x plus 2 is equal to the statement of 9. We're more familiar with equations like 11x is equal to 5x plus 6. Again, two expressions with that equal sign. We also, a lot of times, just set equal to 0. It's perfectly okay for our second expression to be 0. So x squared minus 2x minus 1 equals 0 is an equation. I hope you noticed that the key point here is the equal sign. You cannot have an equation without an equal sign. So when I ask you to solve an equation, I want you to find all of the numbers that make the statement true. These are our solutions or our roots. I may also ask you for the solutions to an equation or the roots to an equation. Equivalent equations have the same solution set. So the equation x is equal to 4, x plus 1 is equal to 5, and 6x plus 3 is equal to 27 are equivalent because they have the same solution set. However, x squared plus 9 and x is equal to 3 are not equivalent because the squared one has a solution set of 3 and negative 3, while the second one, x is equal to 3, has a solution set of only 3. So the solution sets must be identical in order to have equivalent equations. Now, let's talk about the addition and multiplication properties of equality. Suppose I've got real numbers, a, b, and c. If I tell you that a is equal to b, and then I add some real number c to both sides, so a plus c, that is going to be equal to b plus c. So as long as I add the same number to each side, then I have not changed the solution set. I have equivalent equations. Now, if I say that a is equal to b and c doesn't equal 0, that's really important, then a times c is equal to b times c is also true. So you can add the same number to both sides of an equation or multiply both sides of an equation by the same number, except by 0, and you will not change the solution set. Now, a linear equation just means it can be written in the form ax plus b equals 0. We have only one variable, and that variable is x. A and b are real numbers, and a cannot equal 0. Now, a linear equation of the first is called a first degree equation because the highest power is 1. So when we say ax plus b, the power of x is 1. So in this equation right here, 3x plus the square root of 2 equals 0. This is a linear equation because the highest power is 1. It's okay that I've got the square root of 2 there. It's irrational, but it's okay. All I'm looking at is the power of x. The same for 3/4 x is equal to 12, and 0.5 times x plus 3 is equal to 2x minus 6. The highest power for the entire equation is 1. However, these are nonlinear equations. So because I have that square root of x, this is no longer a linear equation. Because I have 1 over x is equal to negative 8, it is nonlinear because I have that 1 over x in there. And of course, when I have an x squared or an x cubed, I'm going to have a nonlinear equation. So suppose I want you to solve a linear equation. Where do you start? Well, suppose I'm given negative 4, parentheses, 3x minus 5, is equal to 3 minus parentheses, 8x plus 7. The first thing you want to do is distribute. You're going to take that negative 4 and distribute it to the 3x and get negative 12. Take the negative 4, distribute it to the negative 5 and get positive 20. On the right side of the equation, I'm just going to bring that 3 down, but this negative is really a negative 1. So I'm going to take negative 1 and multiply by 8x, and then distribute that negative 1 to the 7 as well. This is where most students make the mistake. They forget to distribute that negative to both terms. Next, you're going to combine like terms. So on this case, you're going to add the negative 12 to the right, so you get 4x on the right. Add the 4 to the left on both sides, and you get 24. And finally, divide through by 4 to get x is equal to 6. So your solution set is 6. So if I ask you to solve it, you can give me x is equal to 6. If I ask for the solution set, I need the set notation. Now, suppose I want to solve a linear equation when I have fractions. Fractions are your friend, but we also want to get rid of them as quickly as possible. So the first thing you want to do is multiply by the least common denominator. Now, the least common denominator between 10, 2, 5, and 5 is 10. So when I multiply both sides of the equation by 10, I can distribute that 10 to all of the terms, and it should get rid of all of my fractions. The 10 will eliminate the denominator for the first term, and then 10 times 2 gives me 5, so it'll be minus 5x. 10 times 2/5 becomes 4 times x, and then 10 times 33 divided by 5 is 66. Next, we're going to collect like terms and divide both sides. Now our solution set is negative 10. Sometimes we want to classify our equations. An equation that is true for every number is an identity. So 3 times x plus 1 is equal to 3x plus 3. This is an identity. Now, if an equation is true for some numbers but not all numbers, this is what you're used to using. This is a conditional equation because when I solve this, I get x is equal to 2. This equation is only true when x is equal to 2. And now, sometime you get an equation that has no answer, and this is a contradiction. So if I get x is equal to x plus 1, this is a contradiction. It has no solution. Now, if you're solving a linear equation and you get a true statement like 0 is 0, 1 is 1, then you have an identity, and the solution set is all the real numbers. Now, if you're solving a linear equation and it gets a single solution like x is 3, x is 5, this is conditional, and the solution set is just that one element. If you're solving and you get a false statement, like negative 3 is equal to 7, 0 is equal to 1, that sort of thing, then you have a contradiction, and your solution set is the null set, and that's the circle with a line through it. So we need to decide whether the equation is an identity, a conditional equation, or a contradiction. And if we can solve it, we need to give the solution set. So if I look at this problem and I add negative 4 to both sides and 9 to both sides to combine like terms, and next I'm going to divide by 2, I get x is equal to 11. I have a single answer, so this is a conditional equation, and the solution set is just 11. Now for 10 plus 14x is 7 times 2x minus 5. I need to distribute the 7 to both terms and then collect like terms. And I get 10 is equal to negative 35. Now, this is not a true statement, so we have a contradiction, and our solution set is the null set. Now, looking at this problem, the first thing I need to do is distribute that negative 3, collect like terms, and I get the statement when I add x to both sides and negative 3 to both sides is 0 is equal to 0. Now, this is always a true statement, so this is an identity, and the solution set is all real numbers. A formula is a literal equation, and usually we're asked to solve for one of the variables. So if I were to ask you to solve d is equal to RT for t, then what that's telling me is I want to isolate t using PEMDAS, using good algebra skills. So I want to divide both sides through by r, so I get t is equal to d divided by r. Suppose I want to solve s is equal to kr squared plus krl, and I want to solve it for k. That tells me I need to identify the k and then factor k out. Now k is being multiplied by this sum, but those parentheses tell me I can move that as a unit. So I can divide both sides through by r squared plus rl. And so k is equal to s divided by r squared plus rl. You do not need to do any more factoring or anything else with your denominator. Now suppose I want to solve 11y plus 8 is equal to 2 times 4y plus 5w minus 6z, and I want to solve it for y. The first thing you always want to do is distribute, so you can get rid of those parentheses. So you distribute that 2 to the 4y and 2 to the 5w. Next, you want to collect like terms. So we're going to get all of the y's on the left, and then we're going to subtract 8 from both sides to get all of the numbers to the right. And now in order to isolate y, I need to divide by 3. Now, suppose a man borrowed $2,580 to buy new kitchen appliances for his home. He will pay off his loan in 9 months at an annual simple interest rate of 6%. How much interest will he pay? Well, you remember the simple interest formula is I is equal to PRT. Now, we recognize from the description that the principal is 2,580. That's how much it started. The time is going to be 9 divided by 12. Why 9 divided by 12? Because he's paying it off in 9 months, and he has an annual simple interest rate. So annual means 12. So there are 12 months in a year. So what part of a year is he going to pay this loan off in? And that is 9 divided by 12, or 3/4 of a year. And the rate, you remember, you always convert your rates to decimals. So 6% is 6 divided by 100, or 0.06. So we're looking for the interest, and that's going to be the principal, 2,580, times the rate, which is 0.06, times 3/4, or $116.10. So he will pay $116.10 in interest. The sentence is an answer. When we ask how much interest will he pay, we want a sentence with correct units explaining what you've done.